Hi, I'm Lauren Hirschau, inventor of the Brunton Axis Transit. In this video, I'm going to describe how the axis can simultaneously measure the strike and dip of planar features. But first, let's briefly discuss why geologists measure planar features in the first place, and what strike and dip are. So what types of planar features do geologists care about? Perhaps the most common is sedimentary bedding, or layering, which originally starts out horizontal, but can get tilted into any orientation through earth processes. Metamorphic foliation, the alignment of minerals due to pressure, is another common planar feature that is important to measure in the field. Structural features such as faults, joints, fold limbs, conjugate fractures, veins, and deformation bands are also planar features that can be measured in the field. Why is it important to measure the orientation of planar features in the field? Well, these measurements provide discrete, mappable, three-dimensional data that can help us unravel past geologic processes, or find natural resources, or better understand natural hazards. A complete planar orientation measurement consists of three parts: strike, dip angle, and dip direction. With planar measurements, the horizontal reference plane is really important. Strike is the directional bearing of the intersection line between the plane being measured and the horizontal reference plane. Because it is a line, the bearing of strike can have two possible directions that are 180 degrees from each other. Both are correct. The full description of strike is the directional bearing in either azimuth or quadrant format. Dip angle is the vertical angle between the plane being measured and the horizontal reference plane. A horizontal plane has 0 degrees dip, and a vertical plane has a 90-degree dip. Strike and dip angle are not enough, though. Those two alone result in two possible planar orientations that both have the same strike and dip angle. You should always take note of dip direction to clarify which plane you are describing. Dip direction is the direction in which water would flow down your measurement plane, and it is always perpendicular to strike. A simple cardinal direction for dip direction is usually sufficient. So, the complete description of a plane consists of strike, a directional bearing, dip, a vertical angle, and dip direction, a cardinal direction. The axis is the only transit that can simultaneously measure strike, dip angle, and dip direction on any plane at any angle. For all planar measurements, the lid of the axis should parallel the plane being measured, and the compass face should represent the horizontal reference plane, so it should be level. The major axis is your main measurement axis for strike and dip. If you can walk right up to the planar feature you're measuring, then you can use the contact method, which means putting the transit into direct contact with the outcrop. If you're lucky enough to have a nice flat surface that represents your measurement plane, the first step is to place the lid of the axis against that measurement surface. You also can smooth out uneven surfaces, if desired, with a non-metallic mat board or your notebook. So with the lid against the measurement plane, the next step is to level the compass face using the round bullseye level or the side vial levels if the top of the compass face isn't visible. Leveling the compass face will involve rotation around the major axis and also swiveling the lid on the measurement surface itself until a level compass face is achieved. Make sure that the hinge is only rotating around its major axis. For strike and dip measurements, the minor axis should be locked in its 0-degree position. So when the compass face is level, press and release the needle button 3 times to allow the magnetic needle to reset. Then strike can be read off of either end of the magnetic needle, since strike has 2 possible correct directions. Dip angle can be read on either hinge dial, but make sure that you pay attention to the lid configuration. In standard configuration like this, dip angle should be read where the hinge dial meets the top of the dip indicator. In the alternate lid configuration, read the bottom of the dip indicator. Dip direction can briefly be noted when the axis is still oriented to the plane being measured by looking at the magnetic needle. Dip direction always is perpendicular to strike, and it is the direction in which water would flow down your measurement plane. It isn't just the direction that your measurement surface faces. Sometimes it will be the general cardinal direction or quadrant pointing away from the hinge. In this case, dip direction is towards me. Sometimes, though, it will be in the opposite direction. There isn't a magic button for this. You have to be able to visualize your measurement plane to properly measure it. So let's review this basic strike and dip measurement. The first step is to place the lid against the plane. Next, level the compass face by swiveling the lid and also rotating around the major axis. When the compass is level, press and release the needle button. Read strike off of either end of the magnetic needle. Read dip off of the hinge dial, in this case where it meets the top of the dip indicator, and then take note of dip direction. I could also measure the orientation of this same plane using the alternate configuration of the lid, where I've rotated it around its minor axis. This method doesn't have any advantages over the other, except that it helps visualize the horizontal plane and dip angle even better. In this alternate lid configuration, the only thing to do differently is to read dip angle at the bottom of the dip indicator. If this is hard to remember, just look closely at the hinge dial marks. Only read them where the hinge dial is perfectly aligned with the dip indicator on the compass in order to avoid errors and confusion. Most planes can be measured with either lid configuration. You'll get used to which is easier and which you prefer for particular situations. So now let's take some strike and dip measurements of a variety of different planes. With overhanging surfaces, it's important to visualize the plane being measured. In this case, the plane dips away from me, even though this surface is facing towards me. So to measure the strike and dip of this overhanging surface, I could use standard lid configuration, or I could use alternate lid configuration and end up with the same strike and dip. Planes with dip angles of less than 10 or 15 degrees used to be really tricky to measure with other transits. But with the axis, with the alternate lid configuration, strike and dip can be simultaneously measured of very shallowly dipping planes. A common case is that planes don't create great measurement surfaces, like this deformation band. With other transits, you used to have to use other objects, like mat boards or notebooks, to extend or create a measurement surface. But with the axis, the lid can do that for you. The final thing to discuss is when you can't use the contact method to measure strike and dip. If a plane is unreachable, or if it's preferable to measure from a distance, you have to use the sighting method. With the axis, you can also simultaneously measure strike, dip angle, and dip direction using the sighting method. For example, let's say this bedding surface is better measured through sighting because I can average out its irregularities that way. Before I take any measurements, I want to make sure I'm directly in line with strike to avoid measuring apparent dip instead of true dip. An easy trick for this is to use the disappearing plane method. With the planar surface in view, slowly walk until the plane disappears into just a line and don't go any further. Then you know you're directly in line with strike. Now with the axis at eye height, you can sight your measurement plane through the sighting tube, rotate the lid and align it with the plane being measured, level the compass face using the side vial level, and press and release the needle button 3 times to reset the magnetic needle. Then you can move the compass away from your face to take note of strike, dip angle, and dip direction, which in this case is off to my left. To sum up, the axis can simultaneously measure strike and dip of any plane, in any direction, and any configuration. The lid should always be parallel to the plane being measured, and the compass face should always be level as the horizontal reference plane. The major axis is the important measurement axis for strike and dip. If the lid started on top in standard configuration, read the top of the dip indicator. And if the lid started on the bottom in alternate lid configuration, read the bottom of the dip indicator. And that's how to measure strike and dip with the Brunton axis.